Okay, so we're on section 9.2, and that deals with the topic of series, which are basically sequences with all the terms added together. And the most important one that we're interested in kind of series is called infinite series. And that's because a lot of functions that we've dealt with in the past can be represented as infinite series instead of just in the normal way. For example, trig functions, sine and cosine. So that is one thing. What is a series? And then the second thing is we're going to start talking about the idea of convergence. What does a series convergence mean, or diverge? What does it mean when it converges or diverges? And we're going to talk about a specific kind of series called geometric series, which has a fairly easy rule. So we'll be able to do problems where they're geometric series, and we'll be able to say whether something converges or diverges based on actually whether it diverges. We'll necessarily be able to say if it converges based on a rule that we learned in this section. So the problems that I have assigned are starting with number 3. And it says find the first 5 terms of the sequence of partial sums. So let's look at 3, which is 3 minus 9 halves plus 27 fourths minus 81 eighths plus 243 sixteenths. You see what it is this is 3 to the first power, 3 squared, 3 cubed, 3 to the fourth, 3 to the fifth. You have this alternating pattern. So if we had commas between these, we'd have a sequence, but a series is where you actually add them together. So the partial sums, you have S, I guess we start with 0. We start with 0 or 1. Can we start? It doesn't matter. I guess we'll call this the first term. We'll call it S1. S3. Okay, S sub 2 is the first 2 numbers added together. So it's 3 minus 9 halves, and we'll convert that to halves. So this will be 6 halves minus 9 halves, which is negative 3 halves. Okay, the next partial sum is we add the first 3 things together. In that case, we will convert to fourths, so that'd be 12 fourths minus 18 fourths plus 27 fourths. And if we took the first 2 terms, we would get negative 6 fourths, would be negative 3 halves, so that checks out. Okay, so I'm going to add these in the numerator, so we'll have 12 minus 18 plus 27 is 21 fourths. The fourth partial sum is we add the first 4 terms together. In this case, the denominator is going to be 8. So this will be 24 eighths. And multiply, so we multiply numerator and denominator by 8. Here we multiply numerator and denominator by 4. So we get 36 eighths. Here multiply by 2, so we get 54 eighths. And we subtract the next one, which already has the common denominator. So we get 24 minus 36 plus 54 minus 81 is equal to negative 39 eighths. And then the final partial sum will be 3 minus 9 halves plus 27 fourths minus 81 eighths plus 243 sixteenths. So now we need to convert to sixteenths. So we get 3 times 16 is 48. So we get 48 sixteenths. Multiply 8. Is that right? 72 sixteenths. If you do those two, 48 minus 72, oops, 48 minus 72 is 24. 24 sixteenths times 3. Yes, okay, just gonna do a double check. Okay, so that's 27 times 4. We get 108 sixteenths. Then we multiply by 2, so that's 162 sixteenths. And then we have the last one, which we don't need to change because it already has the common denominator. So we take 48 minus 72 plus 108 minus 162 plus 243. And I get 165 sixteenths positive. So it goes negative, positive, negative. Oh, positive, negative, positive. So it alternates. And this number I think is getting bigger, so I don't think this will probably not diverge because the nth term doesn't go to 0. Ultimately, it doesn't. If we wanted to, what is the terms of the sequence or the series, it would be -1 to the n plus 1. What that'll do is it'll make that positive, and then we have 3 to the n power divided by 2 to the n power, 2 to the n minus 1 power. I think that's right. Because when n is 1, this is positive. You get 3 to the first power, which is 3, divided by 2 to the 0 power, which is 1. And then if you go to n equals 2, which would be this one, you'll get -1 to the third power, which will give you a negative number. This squared, and this to the first power. And then so on. So I think that would be the mathematical expression. We don't know how to solve whether this is convergent. Well, we know it's divergent because when n goes to infinity, I don't think this thing goes to 0, but they're not asking for that. They're just asking for the partial sums here. And number 6 is actually an equation form. So it's a summation from n equals 1 to infinity of -1 to the n plus 1 over n factorial. So what we'll do is we'll just figure out what the terms are. So the first term, let me make sure I'm using the right terminology here. Yeah, okay. So A1 would be -1 squared divided by 1 factorial. A sub 2 is -1 cubed over 2 factorial. A sub 3 is -1 to the 4th power over 3 factorial. -1 to the 5th power over 4 factorial. And the 5th term is -1 to the 6th power over 5 factorial. And so what do we get here? Well, -1 squared is 1, divided by 1 is 1. Okay, so that's 1. Here we get negative, because it's to the odd power, over 2 factorial, which is 2. So we get -1/2. Then we get positive 1 over 3 factorial, which is 6. Then we get -1 over 4 factorial, which is 24. And the final one is positive because we have an even exponent. So we get 1 over 5 factorial, which is 120. So 2 factorial is 2 times 1, 3 times 2 times 1, 4 times 3 times 2 times 1, 5 times 4 times 3 times 2 times 1. So that's how we get the factorial parts. So the partial sum, S1, is going to be that. Then we get 1 minus 1/2, which is 1/2. S3 is going to be 1 minus 1/2 plus 1/6. So we get 1/2 plus 1/6 is going to be 2/3. Because what we get is half, which is 3/6 plus 1/6 is 4/6, and you can simplify that down. Okay, S4 is 1 minus a half plus a 1/6 minus a 24th. Okay, well, we've already gotten these. It's 3/2, 2/3, otherwise it's 3/2, minus 1/24th. So let's put it in 24ths. So this is 16 24ths multiplied by 8 minus 1/24th, which is 15 24ths. And S5 is going to be 1 minus a half plus a 1/6 minus a 24th plus 120th. And I've already gotten the first 4 terms, 15 24ths minus or plus 1 120th. And so multiply by 5 to get the same denominator. So 5 times 15 is 75. 5 times 24 is 120. So I get 76 over 120. So those are the first 5 terms of the sequence of partial sums. So the sequence of partial sums is a set of numbers: 1, 1/2, 2/3, 15 24ths, and 76 120ths. And that, and there's more as when n goes to infinity. In this case, this nth term, this last term, is going to go to 0. You know, the next one will be 1 over 6 factorial, actually negative 1 over 6 factorial, which would be negative 720th. Okay, the next couple of problems, well, actually, I guess the next 2 problems that I've assigned ask the question of convergence and divergence. At this point, I mean just the question of divergence. We had 2 rules up to this point. The one rule says that the limit of a sub n as n goes to infinity, if that does not equal 0, then it diverges. Basically says to converge, you at least have to have the nth term as n goes to infinity go to 0. If it's not 0, then it diverges. The other one is for geometric series. This is if you have a geometric series which has the form, it's shown in the book here, a times r to the n power summation from n equals 0 to infinity. If r is greater than 1, or the absolute value of r is greater than 1, then it diverges. So those are our 2 rules. And so if you look at problem number 9, which is the first problem I've assigned you, we get the summation from n equals 0 to infinity of 1,000 times 1.055 to the n. So this matches the geometric series form. In this case, a is equal to 1,000, which is just constant. R is equal to 1.055. And it says if the absolute value of r is greater than 1, so it is. So since r, which is equal to 1.055, is greater than 1, the geometric series diverges. Okay, so that's the first one. Number 12 is the next one assigned. So in this case, it's not a geometric series, which is good because then we have an example of both cases. So you get summation from n equals 1 to infinity of n over 2n plus 3. So if you take the limit of n over 2n plus 3 as n goes to infinity, you have like a rational type function, and we have the highest order exponent is 1. So the ratio of those leading coefficients, in this case 1 over 2, is the limit. So the limit of this ratio as n goes to infinity is 1/2. 3 becomes insignificant, so you end up with n over 2n, which then simplifies down to just 1/2. And since the limit of a sub n, which is this term, as n goes to infinity, it does not equal 0, it diverges by the other reason. So since the limit of a sub n as n goes to infinity does not equal 0, then the original series diverges. Okay, so that's all we know. That's all we know about. We know 3 things so far. We know that these 2 things are true, that it diverges. The third one is if R, for a geometric series, if R is between 0 and 1, or the absolute values between 0 and 1, then it converges. Okay, so let's start another video. Okay, this is a group of problems 17 through 22, and it asks us to match up the different results. These are all geometric series because these are the only things we can actually determine the convergence, what the value actually converges to. So that's problem number 17. And what we'll do is we'll go ahead and calculate it analytically, and then we'll find the solution that makes sense. Also notice that there's no negative sign, so we won't have any bouncing around. There's one here that F that actually has probably a negative sign. Actually, there's a couple that have negative signs. No, there's more than, yeah, there's at least 2 that have negative signs. There's actually another one that has negative signs. Seems like there ought to be one that, oh yeah, so A, D, and F all bounce around, so they're going to have the negative signs. And the other ones converge, I think, to different numbers, so it should be fairly easy. Okay, so the geometric series, so A is the constant in front, R is the term in the parentheses that is raised to some exponent. And if you go back to your book and you look under geometric series, you see that the series converges to A divided by 1 minus R. So I get 9/4 divided by 1 minus a fourth. So we get 9/4 divided by 3/4, 1 minus a quarter. And then if we take the reciprocal of the denominator and multiply it out, the 4's cancel out. 9 divided by 3 is 3, and so the answer is 3. Okay, so that's what it converges to. And if we look at our picture, the ones that don't bounce around, we have both B and C, which approach 3. So we'll just take the first term because those are different. So for n equals 0, we get 9/4 times 1/4 to the 0 power, which is just 9/4. So now with this initial point, 9/4, which is a little bit over 2, and 3 being the convergence, that we can say with great certainty that C is the particular series that goes along with that equation. Okay, 18. Summation from n equals 0 to infinity of 2/3 to the n power. Okay, so a is equal to 1, because the coefficient here is 1. Just don't show it. R is equal to 2/3. So my limit of the series, this geometric series is a divided by 1 minus 2/3. So I get 1 over 1/3, which is 1 times 3 divided by 1, which is 3. So that has the same. So this must be the other one. So let's do it at n equals 0, and we get 2/3 to the 0 power, which is 1. So when you plug n equals 0 in here, you get 1 times 1, which is 1. And so we look at the curves, and we were comparing B and C because those are the ones that had limits of 3. And B has this value. Picture B, so this is B, and that works out good because okay, so those are the two that have a limit of 3. 19, let's see what that is. So we have 15/4 times negative 1/4 to the n. Okay, so again, it's a geometric series. A is 15/4. R is negative 1/4. So the answer is going to be A divided by 1 minus R. So in this case, we're subtracting a negative number, so we get plus 1/4, which is going to be 5/4. So now we take the reciprocal of the denominator. Going to take the reciprocal of the denominator. So those cancel out. 15 divided by 5 is 3. Okay, seems to be a popular number. So that's going to converge to 3. Do they all converge to 3? Not really. F converges to 4. This one converges to 3, and it starts, well, that's what we need to do. So we're going to do n equals 0, the first term, and you'll just get 15/4 because this raised to any number raised to the 0 power. So 15/4 is a little bit less than 4. So that looks like A. So A bounces back, goes from 15/4, then it goes a little bit less than 3, and then it reasonably quickly approaches 3 in the limit. The other cases we had of the alternating type things starting at 5 and it's like 5 2/3 for D and 5 2/3 for F. So those are okay. So we got half of them done. 20. Again, this is going to be one that alternates back and forth. So we can find this summation just by, again, pointing out what A is and what R is. So what we get is 17/3 divided by 1 minus the negative 8/9. Make sure I wrote that down correctly. It looks right. Okay, so 17/3, and what we'll get here is 9/9 plus 8/9 is 17/9. So we take the denominator and take the reciprocal of it, and you see we get 3. These cancel out. 9 divided by, okay, so it converges to 3 again, and then we'll do So n equals 0, you get 17/3 again, which is, could be either one of those. 17/3 is 6, 5 2/3. Yeah. So both F and D do that. The question is, what happens when n equals 1? So we'll get 17/3 times negative 8/9, because any number raised to the first power is just that number. So then what we would do is we would simplify that. So what do we get? We're going to get, there's no, I'm just going to have to multiply it, I don't think, see. So let's see what we get. 17 times 8, 130. So it's going to be negative 136 over 27. And the reason I'm hesitating is I don't see that go that far down on either one of those. So what am I doing wrong? I don't really know. So let me just pause here for a second. See what I'm thinking wrong. Okay, yep, that came to me pretty quickly. So that's the second term, but really I need to add these two things together. So I have 17/3 minus 136/27. So if I find a common denominator of 27, so take 17 times 9. 17 times 9 is 153. Divided by 27 minus 136 divided by 27. So 153 minus 136 is 17 over 27. And so if we look at, so that's less than 1. So D is the one that matches that description. So D, if you look at picture D, it's going to approach 3 in the limit. The first term is 5 2/3, or 17/3, and then it goes down to a number between 0 and 1. On number F, it only drops down to a little less than 3. Okay, so we're getting there. It's 21. Summation from n equals 0 to infinity of 17/3 times negative 1/2 to the n. So in this case, A is the same thing. That's why these 20 and 21 end up being the same at n equals 0, because both of these ratios that are taken to a power would go to the 0 power, and so you get the same result. Okay. So and then R is equal to negative 1/2. So what do we have here? So this answer is, when you add all these up, you get 17/3 divided by 1 minus 1/2, which is 17/3 divided by 1/2. Actually, it's minus and minus 1/2. So that's going to be 3/2. Okay, so then we take 17/3 multiplied by the reciprocal denominator, and we get 34 over 9, which actually is not quite 3. So it was hard to tell off that graph what they actually approach, but it turns out it's not. You get 34/9, which also goes along with F. So I think I'm just going to say it's F. The initial point is the same, 17/3, when this is 0. And you can see the limit is not the same. Here the limit was 3. the actual series sum of the individual terms. Here it's 34/9, which is more than, it's closer to 4, which if you look at the graph, it actually is that way. And so we kind of know by process of elimination that the last one is going to be the one we haven't chosen yet, which I forget which one that is. F, A, B, C, I guess it's, is that D? No, we already chose D. This is D. So D, E, it must be E. Okay, so we know it's E. So we have 2/5 to the n power. So A is 1, R is equal to 2/5. So the actual series, infinite series, converges to 1 over 1 minus R, which is 2/5. So we get 1 over 3/5. Take reciprocal, you get 5/3. And you see E does approach 5/3. It doesn't approach 3 as a lot of the other ones do. So we can say there at that point that 22 matches up with E. Okay, the next problem is 36. So it says find the sum of the convergence series. N equals 1 to infinity of 4 over n times n plus 2. So, because I thought all we knew right now was that the convergence of a geometric series. So the question is, what do we do? Do we just do it until we, oh, is this a telescoping series? I think it is. So that's the other one we know. Let's see. So what we need to do is use partial fractions. And then we can take the limit of the terms, the individual terms, and then that'll give us the answer. So that must be how this thing works. Okay, yeah. So this is going to, what we're going to do is use partial fractions. So what we want to do is have the original situation here become A over n plus B over n plus 2. So we cross multiply and we'll get A times n plus 2 plus B times n. So this times that and that times that is equal to that. And now we can choose n. So if we choose n equals 0, what will happen is we get B is equal to 2A. Because n equals 0 gives me just 2, so A is equal to 2. And we can let n equal -2. And what that will leave is 4 is equal to B times -2, because this term will go to 0. So B is equal to -2. 4 divided by -2 is -2. Okay, so the original series can now be written as this. We get 2 over n and plus the summation from n equals 1 to infinity of -2 over n plus 2. Okay. So what do we have now? Do we have a telescoping series? Well, actually, let's see whether we have it. Let's just start with n equals 1. And what we'll have, so we're going to come back to this. So we may not even use that. So you'd have 2 over 1 minus 2 over 3. Okay, so that's the first term. So I'm putting n equals 1 in here. N equals 2. I get 2 over 2 minus 2 over 4. And n equals 3. Okay, so we're going to start off chapter 9. Minus, talking about sequences, 2 over. So our first homework problem is problem number 5. And this first group says, write the first 5 terms of the sequence, give me the equation. 4. So number 5 is a sub n over is 6. The sine of n, so what's happening over 2 is we have, and so we always start at n equals 1, and then we increment it to that. So the first 5 terms, and then a sub 1 is going to be root 1 substituted. I'm going to have 2/5, and a sub 2 is going to be 2 substituted. And so this will cancel out that, and then I'll have 2/6, and you see all this stuff cancels out. We're just going to fill in the last term goes to 0. So the only 2 terms that I have are this term for the first 5 numbers. And so the answer should be 1. If I did it correctly. This is an even problem. So, okay, so those will have to change here. We can with me. So I'm trying to think of another way down to pi. See if this is true. It's fine. Here we get the sine of some 2 pi method. So I'm going to use this, and so just all this is true. So this will be our first 5 terms. And from the unit circle, so we'll draw a unit circle. Here's our x-axis. Here's our y-axis. So what we're going to do is this is the nth term, a sub n, and we'll have 1, 2, 3. And remember, the sine of theta equals the y value. So pi over 2, you get 1. At pi, y is equal to 0. At 3 pi over 2 is negative 1. So the nth term is back down to 0 of this series. And then 5 pi over 2 is the same as pi. So our first 5 terms, if we want to, do a sub n, which is that the set of the numbers in the sequence, we'd have 1, 0, negative 1, 0, positive 1, and then dot, 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 dot. And that would continue on. The second problem we have is 8. And this is a sub n. So our equations for the terms in the sequence are negative 1 to the n plus 1 multiplied by 2 divided by n. You see, again, we're going to 0. A sub n is approaching 0, which is good. Go through the numbers 1 through 5. So this one is equal to that. And then this one, the sequence, with an infinite number of terms. We're just going to do the first 5 terms. So again, I can copy a sub 1 is going to be negative 1 to the 1 plus 1 power and times 2 divided by 1. The second term is negative 1 to the 2 plus 1 times 2 divided by 2. The third term is negative 1 to the 3 plus 1 power. I should have added something. And we set 2 divided by 3. A 4 is negative 1 to the 4 plus 1. Yeah, I should have added 2 together. Which gives me 3. And the fifth term, 1, is negative 1 to the 5 plus 1 power. Okay, now let's go back. And then we have 2 divided by 5. Add a bazillion terms here. So when you have negative 1 to an even power, you get positive 1. So this will give you positive 1. All I'm going to do And you see the pattern. This is going to be the odd exponent, so it'll be -1. This will be
take it down to
even exponent. So we're going to go plus, minus, plus, minus, plus, minus, and then we have the value. So we're going to, this is plus, so we're going to have 2. Then we go to -1. Then we have positive. Then what I do is I will negative copy 1/2. I have these subdivides 2/4 into 1/2. And then this is to an even power, so it's positive, and so it's positive 5.
And let's see, we're down to 2.996002.
So if I wanted to look at the set of numbers that are the terms in the sequence,
I'm sure 3 is the answer.
It's going to be 2, -1, positive 2/3, -1/2, and positive 2/5. Anyway, that's good enough. We'll continue on as we increase n greater than
the answer is 3.
So that's 5. What I did here is I took the original expression, rewrote it as partial fractions, and then I found the coefficients.
I rewrote it.
So the next group of problems is 15 through 20 terms. So it's 6 problems, and what we're supposed to do is go to page 602
except these
and try to match up the equations with the pictures.
That's an interesting one.
Okay, so
do one more on this.
Let's just write down all the equations. 39. So here we have the summation from n equals. And one thing you have to kind of think about is what is the behavior of these functions
to the end.
So this is a geometric series. The first thing you do is you look at the initial values.
So A is equal to 1 and R is equal to 1/2.
So when n equals 1, answer, and then you can also look at how the behavior is
over 1
as n gets large.
1/2. And so the answer is going to be 1 divided by 1/2.
You can also look at, is there an alternating sign? Does it go negative and then positive and then negative? And then after that, you might think about other things. But the one actually, one of the things about limits of 42 series is if you went and looked at the function,
another
so instead of a sub n, if you looked at f of x is 8x over x plus 1, you take the limit of this as n goes to x goes to infinity. You have this rational function where the highest order term is x to the first power, and you take the ratio of leading coefficients. So we know that the limit of this particular one says that as n goes to infinity, summation of a sub n is going to be equal to number 8
to a.
So we would look on the graph and see if we see any that have a limit of 8, and the only one that has a limit of 8 is a.
Since we're subtracting,
and so this is going to be a.
So we're adding, so we get 5/3.
Now here we have
3/5, which is 6/5.
Something that is 0.5 raised to,
and let's just show this works.
So we'll go to larger and larger parts. This one's going to go to 0 as well. This one goes to 0. This one probably goes to 0 because factorials get very big. If you look at all the functions that are remaining, the only ones that are remaining are b, e, and f.
So
they all approach 0 as n goes to infinity. So now, and you can also see that e and f start out at 4. So one of these doesn't equal 4 when n equals 1. Well, this one equals 4 when n equals 1 because you get 4 times 0.5 to the 0 power, and any number to the 0 power is 1, so you get 4. So at n equals 1, this is 4, and at n equals 1, this is also 4. 4 to the first power is 4, and 1 factorial is 1. So both of these start at 4, whereas this one starts at 8 over 1. Actually, that one's also 4. Yeah, so they don't start at 4, do they? Yeah, actually, they do all start at 4. Okay, so that didn't help.
It was 0 because you get a negative number.
One of these is going to
so a sub n is that, and this is the sum. So the sum, you take the first number,
positive. It's going to be first get bigger and then smaller.
So this one is always going to get smaller. It's always going to be decreasing, monotonically decreasing.
And then
this one, let's think about this one. So when we did n equals 1,
and looks like
we're
we're approaching
1
1.2.
factorial, which is
1.2
okay, let's do n equals 2. You get 4 squared divided by 2 factorial.
Okay.
So that's 2
get
factorial is 2
1.2
times 1, so that's 2. And so we get 16
Go back to
over
our
2, which is 8. So this is the one that actually increases first. It goes from 4 to 8. But then as you get larger and larger numbers, n factorial starts to become larger than this,
which is,
and so this one, as a consequence of its initial behavior in the first two steps, is going to be a number plus, it's going to be b. Okay, so now we're back to, we only have 2 left.
What is a sub n?
So this one's, well, let's try to think if there's a geometric series of some sort of b. Okay, so these two, one is e and one is negative. So how do you find that out? Well, you could plug in n equals 2 into both of them. For n equals 1, we get 4. So n equals 2 here.
N is equal to 0.
8 over
becomes 1.
So you get 3, 8 thirds. And here, n is 4 to the 0.51. That's a half.
You get
raised
3
to the
times negative
first
1/3,
power,
which is negative 1.
because n
N is 2. You get
2 minus
3
1 is
times
1.
negative
A half
1/9.
is 0.5.
Actually,
So you
2
get
becomes positive 1/9.
2.
Okay, so that's the answer.
So this one's 2,
So
this
our
one's 8 thirds,
series
which is greater than 2. So if you look at the two graphs, you'll see f has a value of
3 times negative 1/3
a sub n
to the
a sub 2 as being
The reason that
8
helped
and this one, being able to figure this
E
one out is
because
because
it either had to be a telescoping
make
series
decision
or
here.
this is going to be f.
geometric series, because that's all we know. And this one is going to be e.
And so I knew it had to be a form of a
the
times
answers.
something to the n power, and I knew this thing got smaller, so I knew it had
So we didn't have to
fraction.
plot out the whole
And it
thing.
had to
We
be
didn't have to
negative
calculate all
because
the points.
I
We
had
looked at
alternating.
some general characteristics. First, we looked at
So
ones that
now that
alternated.
we put it in the form that we need to put it in.
This one alternated
we know
between
that A
negative
is
1 and
3
positive 1, so
and
that one was
R
easy.
is
This one
negative
alternated
1/3.
positive and negative, but
So the
as n became larger,
actual
this fraction became
summation
smaller,
here
so
is
it
going
kind
to
of went
be
like
A
this.
divided by 1.
So we got
minus
those two.
R, which is negative
Uh,
1/3.
We had one case where you didn't
So we
start
get
off with
3
4, so I
divided
just stuck in n equals 1
4/3
here. And
which is
actually, I
3
looked at
times 3/4
this limit. All these three had limits of
be
0, or at least 2, 5. These two had limits of 0. This one's not quite so obvious.
So since we already have the spreadsheet set up, let's just do this
As n goes to
again.
infinity.
All I have to do is change the equation.
And then I ended up just plugging in one value to tell the difference between these two.
Okay, so there we were. That's what we had before. And in this case, our new equation is 3 and negative 1/3. Okay, so I'll change that to a 3.
Okay, our next problem is
Change that to a
26.
1. So we get 3. And
So these groups say,
then
write the next
copy
two
that
apparent
here.
terms of the sequence. Describe the pattern that you
there,
use to find these
and
terms.
you can see quickly.
So here we have the term 2.25 in your book. 7
So
halves,
our first term was 3.
4,
Next term was negative
9
1.
halves,
2.
5.
You add that, you get that. So you just keep adding each
Dot.
one of these to this previous
Okay,
sum.
so
And you
what
get
I see is
value.
it may not come directly to you, but what you would see is if I wrote
Okay,
all
let's do one
these
more.
with the same denominator, you can rewrite 4 as 8 halves, 5 as 10 halves,
So we had 45.
and then you should see an obvious pattern here.
58.
So if they don't ask us to write an
So
equation, we're
determine
going to
what is
come up
the
with one here.
determine convergence.
So what
or
the first term
divergence.
is
So
7.
they don't ask us to find the
So
value. They just
we'd
say,
have
does
6
it converge,
plus
does it
10
diverge?
divided by 2.
I guess it converges.
So when n is equal to 1,
okay, so
6 plus
58
1 is 7.
is
When n
this
equals
expression.
2, you get 8. when n equals 3, you get 9, when n equals 4.
So it's not a geometric series.
So that is the pattern that we're looking at. You had to rewrite
the
whole
we
number
have
of
to use
fractions
just
to
at this
see
point
it.
are the
I'm used to when I teach math at liberal arts,
nth term test, which says if this term, if this
simplifying
the
fractions
limit
so that kind of jumped
as
right
n
at it.
goes to infinity of this expression,
Okay, 31.
and that does not equal 0, then it
Actually, that's let's
diverges. So
let's do more than
you
one
can see
of
what
those.
we'll get is 1/2 because
So
it's
write this
a
down.
rational expression. The leading coefficients are
So
1.
let's pick
2.
30.
The highest order term is to the first power, so we take the leading coefficients, we get 1/2. And since this limit,
So 30
limit
is 1
as n goes to infinity
has
of a sub n,
9
if it's not equal to 0, then we know
negative
it
27 eighths. Okay, so one thing we
So
see
really
is this pattern
it doesn't diverge to
of
anything. It just
alternating. So that always means you've got negative 1 raised to some power. It starts out as even, so we're going to have n plus 1, so that when we start with n, 3 to the 0 power is 1, any number to the 0 power is 3 to the first power.
So we continue on with our convergence.
Now,
divergence
so that's
question.
the equation.
So the next one is signed. Actually, it's very similar to the one I just
But I
did.
could take this
For the
same
same
combine
reasons.
them into one term because I have to
If you
take
take the limit
exponent
of this,
so I get 3/2 to the n minus 1.
the
So
nth term,
here I'll have
as n goes to
3/2 of the 0, which
of
is
this,
any number to the 0
it
is 1.
becomes
And then when n equals 2,
3/2.
3/2
And
is the
so
first power, 3/2 is the second power,
this
3/2
limit-
is the third power.
The limit as n goes to infinity.
So that will be the next expression.
So since
Okay, so do one more in this
the
set.
limit as n goes to infinity.
So
of
factorials are important.
a sub
So
n does not
finding
equal
the
0,
ratio
the series
next one's
diverges.
31. If you ever take statistics or probability, which you have actually, most of you have had it.
Okay, 64
you
is
end up
a
with evaluating ratios of
Doesn't look
factorials.
like it initially, but
And remember,
one thing you'll notice also is when we
factorial-
start at 0, it's
let's say
a
seven
geometric
factorial
series. When
is
it's
7
not
times 6
0,
times
it's
5
usually
times
some other kind of series.
times 1.
So what we can do is,
Or
we can
It
rewrite
can be
this
represented as 7 times 6 factorial, or 7 times 6 times
As
5 factorial, etc.
one.
You can
You can group these two
terms and rewrite them as
1
factorials.
to
So
any
this
power
3 would be
is
3
still
factorial.
1.
These 4 would be
So I
4
can rewrite that
factorial,
and bring that
these 5
inside. If I-
etc. So
I
what we
took 1
do
to the
is
n power, I get
to,
1.
instead of just multiplying this out
Again.
in the calculator,
So at that point,
we can
we
simplify
know
it
how to
and make the
geometric
numerator
series.
10 times 9
because this
times
number
8
is
factorial
is
is less
less
than 8
than,
factorial, because that's what I have in the
between 0 and
denominator.
1,
So
you know it converges.
8 factorial divided by 8 factorial, well, any number divided by itself is
So
1.
it converges.
So this just becomes 10 times 9,
R is
hence
equal
the
to
n is
190.
94, which is a lot easier to multiply 10 to the 9 than it is to multiply this all the way
The
out.
actual
10 factorial
value
is
that
the
it
big
would
number,
converge
and 8
to would
factorial is
be
equal
to
the big number, not quite as big as 10 factorial. So that's the way you should do it.
3/4,
Anytime you see these ratios.
So it actually
Converges
converges
to
to
that.
that.
They didn't ask us whether what it converged to, they just asked us whether it converged or not.
And
Okay, next
67
is 34. So we're still talking about factorials, which is interesting. In this case, it involves the variable
over the
n.
natural log of
n. So
So
this
actually,
one looks
if you
like
compare
compare
this
this
to
to problem number
the,
31, which we
nth
just
term
did.
test.
If n equals 8, you'll get 10 factorial over 8 factorial.
And so what we
So
do is
what we can
take
do is
the
we can
limit
rewrite this as
of
n plus
this
2
ratio
times n
as
plus
n goes to
1
infinity. Okay, so how do we
times
evaluate
n
that? Because
factorial.
you put infinity and you get
And we
infinity
divide
over
by
infinity
n
and say,
factorial.
oh yeah, that's L'Hopital's.
So again, in fact, any number divided by
that's
itself,
going to be
any variable
saying
divided by
limit
itself,
as n
is
goes to
1.
infinity
So we end up with n
of
plus
the
2
derivatives
times n plus 1. And we could multiply that
n
out.
is
squared
1. The
plus
derivative of the
3n
natural log of n is
plus
1.
2 if we wanted to.
So what you'll get there
that's
is 1
problem
over
34.
1 over infinity, which is 1
And I'm
over
just looking at the
0,
other problem to
which is
see if there's
infinity.
anything.
And so this does not approach 0. It doesn't even approach a number.
Okay, 38.
It approaches infinity.
Next one.
So
Find
the
the
reason
limit
is
if possible
because
of the sequence.
the natural log of something function looks something like this, so it levels off, whereas this n function increases. So this increases, and this goes to...
Okay, so one way of doing this is if you have a function,
that's why it goes to infinity.
and instead of substituting instead of using n, we use x.
The limit,
and then we take the limit of f of x
as n goes
as x
to
approaches
infinity is not equal to 0.
Limit will be the same as the limit of the sequence.
It diverges. Now, if this approaches some number, it still would diverge.
And so what we can see is that the limit of 5 is just 5. And the limit of the second term is going to be 1 over infinity squared. So this term is 0. So the answer is 5. Which would be 0.
The last two problems and have a series where you actually have an x term.
That's what my initial thought would be.
Over 80.
As x goes to 0, it goes to infinity, so the string actually goes near 0, it goes back and forth real quickly. And then as it goes out, it's going to be spread out. This is plot it.
So which values will this series converge? So this is an example of a
share that with you.
Geometric series. Sort of doesn't start with n equals 0, but it does
Sine of 1
over x.
Now, if x goes to 0, then there is no limit, but this x
converges starting
with
at 0.
We should have something happen here. So yeah, here it is.
So you can see
all we
as
need
x
to
goes
do
to
is make
infinity,
sure that
this argument,
this is going to go to
this is
0.
going to be r.
If we zoom out,
We have to have that less than or equal
you
to
see
1.
that it goes to 0. And if
So
I
all
zoom
we
in
need
the x
for
direction,
is
I need to see it
3x
going to approach 0.
to be less than 1, or x has to be less than.
I'm confident that's
true.
true.
So
And
it
same
can
is
be
true
positive
for
or
the
negative.
sequence.
So we would say for
So the answer is
the
going to be,
series
for this one, is 0. And therefore the limit of the sequence as n goes to infinity is also equal to 0.
Now the only question is, what happens when x equals 0? You really don't have a series. You have 0 to the n power.
Okay, we're still talking about convergence. We're going to do problem number 50.
That doesn't make any sense. So we'd actually have to probably...
So the problem asks, determine the convergence or divergence of the sequence with a given nth term. If the sequence converges, find its limit.
1/3.
So our sequence is a sub n
Otherwise, we're in good shape.
equals
So that's how we
cube root
look at that as
n
a geometric series and figure out
divided
how we
by
make it converge.
cube root
Okay, the
of
second
n
problem that I have
plus
is
1.
the summation from n equals...
So the question is,
infinity
does this converge or not?
-1 to the n.
And one way to think
x
about it
to the n.
is,
So I
think
can
what they're wanting
this
us to do here is use the squeeze theorem. So
have negative x to the
you
n.
can see if I take another
And
function
again,
or another sequence,
x to be, in this case,
they would
less
call it
than x
another
has to be
sequence. I think
at
let's
less
look
than
at
1.
let's look at the squeeze theorem.
To 0 for the absolute value. So again,
So the squeeze theorem says if
this
you have two functions
cause it to
that
converge,
converge,
and x does not equal 0.
and your function
So those are
is
the limits on it.
between those two functions, then
And it says for these values of x, right?
your function is going to converge. So in this case, we really only need one other sequence, which is just actually,
so I didn't do that.
if I look at, if I remove the 1, so if I have the cube
So again,
root
because
of
it's
n
convergence,
k
over the cube root
is a
geometric
series, that just
and
ends
I
up
can
being
just
1.
use
And
the
so
result for a geometric
b sub n
series.
would just be 1. It'd
So
be a simple
the-
sequence, it'd be 1, 1, 1,
For
1,
these
1, 1, 1.
values of x,
And
this
this function, a sub n, the sequence, is always going to be
Summation
less
here.
than b sub n.
is going to be equal to 1.
Why is that? Well, let's just look at an example. So if you get n equals 1, you
And
get we'll just evaluate. This is always 1, so we know that if we can prove this is less than 1, then we're in good shape. Because the other function is 0. That's why we only need to do one side.
Yeah.
So what you get, if you get a sub 1, you're going to get cube root of 1, which is 1, divided by cube root of 1, which is 1, plus 1 here, and you get 1/2. Okay, so 1/2 is less than 1. If you do n equals 2, you get a sub 2 is equal to the cube root. Well, let's just pick a 2 divided by the cube root of 2 half, which is no, it's not. Plus 1 equals 6. And that's going to be equal to something that's still less than 1. Let's just do it in our calculator. So 2 to the 1/3 power divided by 1
goes from n equals 0,
plus 2 to the 1/3 power.
I think what I may have to do is evaluate it at 0, and then I can subtract that. So let's see, when n equals 0, you get
so 0.5.
to the
You see
0
it's getting
power,
bigger.
which is 1.
But if n goes to infinity, what you'll end up with is this term will become
n equals 1, it's going to be 1 less,
so you'll just end up with the same number divided by
Okay,
itself,
so
which is 1. So this a sub n is always less than a sub n. And since this converges, because it converges to the number 1, then this one converges. And as a consequence, that is actually what is, if you take the limit of a sub n,
well, I don't need the whole summation thing.
the a sub n, as n goes to infinity,
So the actual
you're going to
evaluation
get
of this thing is going to be that.
because these two terms will become very large.
So what I
to the million
do
power,
is, if I plug that
then
into here, I'll get 1.
the cube root of a million would
1
be,
minus 3
what is the
times
cube root of
6,
a million?
and that will be 1 over 1 minus a half, which will be a half. That equals 2. So that's what you have if you go from n equals 1. So the answer is
So you get 100
less than that.
divided by
So my
101,
answer is going to be 1,
which is close to 1.
minus,
And as this number, as n
over
becomes even larger,
1 minus 3.
it approaches 1.
That'll give me the sum. So, for example, when x equals 6,
Okay, 63 is the
I'll
next
get
one.
this. If I sum from n equals 0, but for n equals,
So we have
for n equals 1,
a
for 0 I'll
is
get
equal
this,
to
but I subtract 1 off
1
because
plus
this is evaluated
negative 1 to the
at
n.
x at n equals
over
0 is just 1. So you get 2 minus 1.
So we also have this
That's my
absolute value.
That's
limit
right.
theorem.
And in the second case, we
So
started
let's write
at
that down. What does it say?
n equals 0
This is on
here.
page 598. So the limit,
I don't have to do
the
anything
limit of
special.
n,
All I have to do
as n goes to infinity,
is
the
say
absolute
that
value
this
n
result
equals
the values of x are
0.
going to be equal to
Then
1
The limit
over 1
as n
minus
goes to infinity
and
of a sub n also equals 0.
so
So,
I get 1 minus x.
if we just do a few points here, let's say n equals 1. For n equals 1, you'll
So
get
those are
1
the actual values
plus a
the
negative 1 to the first power.
So n
series
equals 1 for those over
When x
1,
is between negative 1 and 1,
which is the
equal
actual
to
1
value
minus
is 1 over 1, which is 0.
over 1 minus x.
So that starts out as 0. Now if you do n equals 2,